Thank you for coming. So today I will try to explain you what is Hardsploit tool, and I hope it is the next hardware hacking laboratory. So in fact, it's a framework for hardware hacking, security audit, in fact, and it's a bridge between hardware and software pen tester. I am an electronic engineer from Opal Security. I'm a security consultant in hardware and software. I'm the team leader of a Hardsploit project, and I'm a DIY enthusiast. You understand why just after. Just a few words about IoT, Internet of Things. We have a lot of things now in your life, for example, for home automation, etc., etc. And we need now to focus on security of these embedded devices. So to help software pen tester to find some vulnerabilities, you need to extract a firmware or you need to read something on the target. But in this case, you need to put some wire, you need to plug directly on your board because it's hardware, it's not only the software. It's for that we create Hardsploit based on another project like Bus Pirate, etc., etc. I don't know if somebody here knows Bus Pirate, JTAG, and something like that. I don't know how many people. It's not so bad. Yes, it's the same tool. It's like a tool like these tools, but a little bit different. It's based on firmware, so you can add some feature without any hardware changed. So we understand how it works. Just a second slide, just to explain why it's important to focus now on the hardware. We can find some embedded system with some vulnerabilities like webcam. You need just to read the SPI memory and you obtain the firmware. If you want to backdoor this camera, you need just to read, for example, with this tool, it takes less than 1 minute, and after that you need just to change some code to have a backdoor. It's a common vulnerability, plain text assembly code or optocode for microcontroller in external memory without any protection. And another issue, but with VTech, it's more common IT vulnerabilities, but VTech want to close and shut down all the server because have some trouble with security. And in this case, all the IoT system doesn't work just 1 day before Christmas. So you can see sometimes it's a vulnerability directly inside IoT, and sometimes it's a more common issue. Okay, so in fact, in IoT system, it's an ecosystem, so you have a lot of communication, most of the case wireless. And today, I want to focus only on IoT devices, the PCB board, the hardware, okay? So the first step when you want to do something with hardware, you need to tear down, you need to open, because it's hardware. So you open the box. Sometimes it's not easy because you have anti-tampering system or something like that. So you need to be carefully when you want to open something. In this case, it's already open, so without any issue for me. The next step is to fingerprint your device or devices. These steps, it's easy. Sometimes because you have the name on the top of your chips, and it's not more complicated, and you have a lot of information on the internet to find something about them. But sometimes you can't read the name, and you need to have a more powerful tool, like brute forcing or something like that to find something. And the next step, of course, is to read or write something. The first step is to read, because when you try to do something with the devices, if you try by write, you can change the integrity of your system. So most of the time, you need to read before do something else. And of course, but normally you know that, you need to reverse your code, or you need to understand what you try to do. Yes, it's cool to read something, but after that, what else? So you need to do your job just after that. My goal today is just to explain you how you can extract some information inside the devices with a very simple tool and a very powerful tool in next month, because each day we add some feature on Hardsploit. Of course, the global purpose is to read something. Why? The answer is easy. You have most of the time a password, file systems without any encryption, and firmware. More generally, main global purpose is to extract firmware inside microcontroller or inside external memory. Sometimes it's not exactly a firmware. You can have some a custom protocol, and you have some raw data stored inside external memories. You need to reverse this. We do that just after. Yes, in electronic or in IT, you use Nmap to find something, or to find open ports. But in electronic, you don't have Nmap. And you need to put some wire before. You don't have only one Ethernet port. You need to connect, most of the time, a lot of wire to do something, and in a good way, because if it's the wrong way, it doesn't work. It depends, because sometimes the tool can cross the wire, etc., to do that for you. So sometimes it's very interesting. Just some information about electronic buses. I don't know if you know all this name, but it's the beginning of hardware hacking. It's a common basis to interact with your chips. So most of the time you need to read or interact with SPI and HUC or UART, serial communication. It's very common, and not really now, but for old system or a very big system now, you need to interact with parallel memories. Parallel memories need to put very lot of wire. You need to generate all the addresses, and you need to grab all information. If you have a big memory, sometimes you need to put 20 or 30 wire just to generate addresses. And if you have on 8-bit buses or 16, you need to add 8 or 16 wire or more. So to be short, it's about 30 or 40 wire to interact with something. Sometimes it's not easy, because if you change just one wire, it doesn't work. It doesn't work, okay? So you need to know about that before using a hardware tool, auditing tool. Just to explain Hardsploit framework, you have a board with database with each module. Module, in fact, is like electronic buses, okay? When we want to add and compliant with some, in case of custom module, for example, you can add some VHDL code to interact with without any issue with the speed or something like that, because you are not in microcontroller, you are in VHDL. You can do some process in parallel. So it's complicated to develop, but it's very powerful. When you have your module, of course, you have input and output. In this case, we have 64 pins to connect with something. Most of the time, people ask me, why you have 64 pins? Normally, now you know why. It's because most of the time, I agree, not really now, but it depends. You need to connect to parallel memory. The last week, for my customer, I need to read a memory with more than 20 wires. So I really need this when I process some hardware hacking stuff. Okay? Of course, most of the time, if you use SPI, you need only 4 or 5 wires plus power. I want to add some feature to Hardsploit. For example, bus identification. It's not an easy task because it depends on your buses. But for example, for JTAG or SWD in ARM processor, you can send some data to obtain a response. And if you don't have any response, you can say, oh, it's not a good wiring. You can change the wiring and try again and try again and try again. And after that, you can obtain an access. So the goal of this module is to cross all the wires. And after that, you can obtain an access without any information. For example, I put 8 pins on my system, and I just click on the button, and I take a coffee, and after that, I have a ground access to a firmware. Of course, it depends if it's a protected firmware, but in case of, it's easy for you. And we want to add some sort of scanner, but we need to implement and we need to add a lot of things inside the database for that. Okay. Just to illustrate, to compare, because it's a very common question. What is different with Hardsploit? My main response is based on FPGA, and it's not the same tool. It's more complicated to develop, but when it works, it's a very powerful tool. Because if you say, if you need something one day, you don't need to change the hardware, you just need an update, okay? And this update changes the hardware because it's based on FPGA. Just to show you a little bit how it works, you have a graphical interface, standalone graphical interface with standalone API, and if you need a command line, you can't, but you can instance or create your Hardsploit class. I think it's more powerful than type a lot of command without any information. So, for example, if you want to interact with I2C, you just need to create an object, Hardsploit I2C, and it's enough. After that, you can interact directly with I2C. Okay? You have a microcontroller for USB and FPGA memories to start FPGA, and inside Hardsploit, you have a sort of a core of Hardsploit, and after that, when it's stable, you don't change. You don't need to change anything, and you just need to add some custom module or what you want. For example, SPI, I2C, etc., etc. So I never develop all the things each time. It's just a part of Hardsploit each time. You understand now why a DIY? Because my first board is not very. It's with a low budget style because my CIO won't paid. And no, it's just to begin, and it's very interesting to try by yourself something. And trust me, it's not enough accurate if you want to do something with SMD. It's a component surface mounted, and it's very complicated without any professional tool. But I continue my travel with a DIY oven with PID, or it's not a really PID, it's just a P, in fact, because it's very old school system, but it's worked perfectly for my first batch and my first test. Okay, and we create my own oven to try the first board. The first board is like the green globin. It's not very cool and not beautiful board, and it's too large, etc., etc. After that, we change the tool, and we have on the left a stencil machine to apply a solder paste, etc., etc. It's more efficient, trust me, of course. On the middle, you have a pick-and-place machine to place the component. We create Hardsploit at my company by myself with my colleagues, and I don't put the component, each component on the top of the board. It's too complicated. For example, just a LED, we have 64 LED and a very small LED, and it's very complicated. So the pick-and-place machine takes the component and puts it directly on the top automatically. And on the right, you have a very professional reflow oven for soldering. And now we have the final board. It's like that. You have 64 LED on the bottom with 64 input and output. Input and output, of course, to connect to your target. I have some demo. Just to understand, you have Hardsploit with graphical interface, interact with APA for the low protocol. And the goal is to have something really good. I'm not the best in design something, but the goal is to have something very easy to use for hardware, not hacking, hardware audit, because we are professional here only, of course. The goal is to have all components in my database. So we finish, I hope soon, the platform sharing. The name of Hardsploit is because it's like Metasploit, and the goal is to do the same but for hardware. Okay, so we have the same issue. We need a community to create and maintain all the components inside the database. It's the main issue with this project. But I hope it's not a very big issue, because we want to add some very useful and powerful tool to update this information. So with just a right click or something like that, you can share your work. So I hope we can have a big database after that. Just to show you the graphical interface, but it's not very interesting because I have a demo just after. You can create your own component. I don't know if somebody knows E2C, but it seems to be yes. If you need to interact with E2C memory, you need to have the address. It's not easy sometimes. You need to read the board, etc., etc. In this case, you just have one button to have this result in. I show you just after. It's very interesting. And you can, when I process some hardware hacking stuff, sometimes I need to repeat some command to do something on the target. In this case, you can save it on graphical interface, and after that, you can relaunch or lot of time the same. In this example, if I want to write 2 bytes at 2000 address, it's possible just by clicking, etc., etc. So, if you want to dump or read something, you need just to click on the button, and all things are done by Hardsploit. And you have a binary file just after. What are available on GitHub? All except PCB design for the moment, but all is open. Microcontroller, API, GUI. You can create your own module in VHDL if you want. I provide a template on GitHub if you want to do something. It's easy if you see just on the bottom. It's not complicated stuff if you want to create some module. What's already available on Hardsploit? You can read some parallel memories without multiplexing for the moment. It's a very common memory, and now it's not common. Now the parallel common memories is the same, but we mixed address and data. Is something like SPI, but with more wires. It's not SQI. It's very parallel memory, but it's a little bit different. You have helping wiring. You understand just after what is. It's simple. We have 64 LED here, and when you need to plug something, you have LED light on, single LED to explain to you where you need to put something. Trust me, it's very interesting when you need to put more than 30 wires. Of course, for E2C, you have only 2 wires. Most of the time, you plug, it doesn't work, you cross. But in case of 30, it's not possible to test all the possibility. And sometimes it's a very big issue during an audit because you have a very limited time, and you can't spend your time on very basic stuff like that. We are compliant with E2C, SPI, SWD. SWD, it's like JTAG, but for only ARM processor, okay? And we can interact sort of big banging. I think it's not very useful with this tool because we can implement your feature directly in VHDL with a very powerful system. So if you don't want to have some issue, you can stay in Ruby and you can do something if your system needs a frequency less than 500 Hertz, but it's not very efficient system for that. What is in beta, and I hope publish them very soon. For example, SWD Bus Finder is like JTAGulator. You plug 8 wires, excuse me, and just click on the button, and you can find SWD without any interaction. So it's very interesting system. If you don't want to search some pin, it's good. And the Nordic system is to interact with 2 gigahertz, excuse me, frequency. Some Microsoft keyboard or some devices works with this module. And I implement this because I need this on my training, and it's for that I create, and it works perfectly. We try it at the beginning of the week, for example, but it's not published for the moment. And the big project of Hardsploit, the first big implementation is OpenSSD support. I don't know if all people know this open project, but it's to be compliant with most of, all, maybe, ARM processor, and you have a lot of board compliant and supported by this tool. So my goal now is to have Hardsploit compliant with this board. Why? It's because when you want to interact with some ARM devices, you need to put some very complex settings, and most of the time you need to create all the time exception each time you want to do something. It's too complicated to be compliant with a lot of chips, so I prefer now to create a driver, a sort of driver, to be compliant, and my tool can be supported by OpenOCD. It's in progress because it's worked perfectly for dumping and writing, etc., etc. But I have some trouble for the moment with GDB. So I'm very 90% for the moment. But I'm sure very soon we have something very, very cool. We have the same issue with we are on late. Yes, I'm really on late on command sharing platform because I need this platform to have a very interesting tool because you have only few devices on Hardsploit. It is a less interesting tool. So trust me, very soon we have a big system to exchange some devices, and I hope we can create a big tool to do something. Of course, we had TTL UART is a very common module in VHDL. Trust me, it's not an issue with VHDL to do that. It's worked perfectly, but I not finished automatic detection speed. So it's for that I explain just 90%. But in fact, it's worked perfectly, of course. And I want to add E2C and SPI sniffer, but I'm very late of this roadmap. It's because we are consultant, and I'm not I'm full-time on Hardsploit. And for example, I'm here today, and I do some trainings all over the world. So sometimes it's complicated to find some time to do something. And yes, I want to add parallel memories, multiplexed, because it's very used now, and some wireless transmission training platform to send some information on a very common frequency for training. And I want to add JTAG, but it's not for me the main feature, because for the moment I can be compliant with only ARM processor, and you need to know ARM processor have always SWD protocol, and JTAG is not only the way to do to extract something, and JTAG is not available on some devices. So please don't focus only on JTAG, and for that, for the moment, it's not my first priority JTAG, because I have my first priority, it's SWD, because it's only 2 wire and you can do the same thing than the JTAG, but with less wires. It's better. And we want to add a driver to drive CAN bus, of course. We can do that with VHDL. It's not a very big problem to implement it on VHDL. So just a very fast demo, but we have 15 minutes, so I think it's possible. Just to explain you very fast, on the top you have Hardsploit tool, and on the bottom you have training board. It's just like a fake log system with lots of vulnerability inside. And today we try just to open the door. It's a common log system. When you put a code, you have a red, excuse me, but it's a red light. And when you put the good password, you have a green light on the left. Okay? So the goal is to hack or audit the system, and you need to put A, B, C, D to open the door, or something else. You need to find the password. So the first step, you remember, it's a fingerprint show device. In this case, trust me, if you want, you can verify what I try to explain you, but it's STM-F103 RBT6 device. It's a microcontroller, a very common microcontroller in electronic. And we have on this board 2 E2C memory, very, very common memory. And yes, memories, because it's the same for SPI, it's very common memories. Okay? You can use a probe, a very a cheap probe like that. It's not very, for I2C or when you have only big space, it's good. But for example, if you want to try SPI directly on the memory with this type of probe, it's not easy all the day. I'm sure here I have 10 persons. It can be confirmed my information. So you can use a very expensive tool. It's not expensive, but it's about $50. It's more efficient. Or you have a lot of things to try something, or if you want to put something on chips. My prefer is to remove the chip and you create your own custom reader to do something. You have, most of the time you don't have any issue when you want to read something, because you are alone and you can do what you want, when you want. Okay, but in this case it works perfectly, so we do in live, so we just put some wire on the top of the memories and we try to read something inside, okay? So we just try to start a graphical interface. Yes, my board is connected. So you remember the name of, for example, microcontroller. I click just the detect to be sure my target is here, and it's not here because it's not connected. Yes, of course. But when you connect something, you need to be sure it's in a good way. Yes, I'm lucky. And just after that, you can just click on export, for example, to desktop. Yes, I prepare the name. Yes, why not? Yes, it's enough. After that, you can open the file with hexadecimal reader. And you can obtain some very interesting stuff. So I'm sure it's not very for you, but if you search, you can see something very interesting. It's a string of the firmware, for example. You can read and convert your file, for example, with obj dump or something like that, and you can obtain. Yes, it's very clear here. You can obtain assembly code, of course. So in less than 1 minute, you can obtain something. So be careful. Now we have a lot of very interesting tools to do something with ARM processor, like OpenOCD. You can do these things with all ARM processor like that. So you need to activate the protection, etc., to avoid this type of issue. Yeah, trust me, it's reality. When I audit some devices, I find all the time this issue. All the time I have this issue on embedded system. And with this type of tool, it's very easy to obtain something. We just have the time for a second demo. It's very fast. I need just to unplug and replug. Do you remember I have two I2C memories? Yeah, I have a password. You know, maybe the password is inside. Of course, it's for a demo. Password is inside, and you trust me, it's the reality too. You have the password in plain text inside external memory. Yes. It's sure. I'm sure it's a very common issue. So when you have I2C buses, you need to process a scan. Yes, I click just on one button. I have the result of my scan. I don't know if you know I2C is not the moment to explain all these things, but training is for that. But in this case, I have 4 addresses. Okay, it's because I have 2 memories, and for I2C, you have an address for read and an address for write. So I have 2 memories, and of course, I have 4 addresses. So you need to find something inside the memory. I have 2 memories, but I don't have the time. So trust me, I'm sure something is very interesting on the second one. I'm lucky guy today, so I'm sure. Okay. So, excuse me, just here you can change the memory what you want to read something, okay? You have a scanner to find and you can change. Maybe we can improve the graphical interface if you say me it's not a very good interface. After that, it's not very complicated. We just the same thing. EEPROM or EEPROM2. Oh yeah, EEPROM. We can use the same and override. Yeah, perfect. Yes. So before I send E2C firmware inside the FPGA, and after that, Hardsploit can be interact with E2C. And when I click on full export, Hardsploit reads all the things to extract all the content. Why it works? It's because on the settings, you have the size of the memory, etc., and generate all address, all is done automatically, okay? So, after that, just open the file, and you can have something very interesting. So, good luck to find the password inside this file. It's not, most of the time, easy to find something inside, okay? But, we can do something very interesting like that. I'm sure all people know that. Yeah. It depends, of course. In this case, it works not so bad. You need to find on this. It's better. But you remember we want something like A, B, C, D. So we know what we want to find. So maybe where is? Yeah, here. I'm sure because I verified just before. Yeah. Okay. Something more efficient. Now we do some search because we know what we know hexadecimal, just text. Okay. So just to show you something, I don't remember the ACDA. Okay. So ACDA. So of course we have the green light. You see that? Okay. So what is very interesting, of course, a very big issue on this system. But for example, if I want to change the password, I can just save and sort of replay attack if you want. It's very easy with this tool to do something. Of course, I change just the file and I re-upload the file. It's very complicated stuff, in fact, because you need to create all the pages, etc., etc. It's very complicated to write on something on external memory, in fact. Sometimes you need to put only 16 bytes each time. It depends on the size of your page, etc., etc. So all the things is done by Hardsploit. Or you can use a custom command to change only few bytes, because now you know where is your password or something like that, okay? So we change it, so just upload it, and it's finished for the demo. I'm not sure it's EEPROM, yeah. Yeah, I don't remember, sorry. Yes, it's this file. So we can try again. So we change the password, of course. But just few clicks, you can extract firmware. Thank you. Of course, it's for demo, but it's not for demo. It's real life. And you see, with just few clicks, we can extract, you can change, and you can re-upload the data. It's a very easy way to do something with hardware. And it's very common protocol to do that. Okay? And we want to create the same thing for all the buses, and we need community to do something with that. So yeah, it's enough for demo. And you understand parallel memory. I don't know if you know this router. I'm sure all the people here know that. If you open the box, you can see this flash, for example, and good luck to read something on this flash. Because you did something like that, if you want to do that, it's possible with Hardsploit. You can desoldering and put it on a socket for reading, or you can create your own custom board. And after that, you need to plug a lot of wires. And trust me, it's very interesting. Just one thing, because I explained but no show you, it's very fast. It's wiring. When you click on wiring, you need to plug wire. So I put it very fast because I know the devices, and it's not the goal today to show you that. But for example, if I need to put the HIP16 clock, I have the first LED and the second. You explain it's a second. Okay, for HIP16 two wire. But when you have something more complicated for SPI, for example, you have the same chip, so you take your board in the same way, and you need just to... It's a kid game, in fact. You just the good light with the good pin, etc., and just click on few buttons. Okay? So SPI clock, for example, I don't remember where it is. It has the first pin. CS, it's the second. MISO, etc., etc. So it's easy to understand when you need to put something. Okay. Of course, for parallel memories, you understand it's very interesting. Helping wiring system, helping system wiring is very interesting to help you to wire this cable. And after that, you can extract the firmware. In this case, it's a file system, so you need to use binwalk or something like that if you want to do something. Okay, so the conclusion is I don't have any conclusion, but because it's my job, but you need to be carefully. You have a lot of tools now, and we want to create some tool to help you to find some vulnerability in your devices, to improve your security. And the designer need to design with security in mind. It's very important because you can read something like engineer can write something. Last year, I do some hardware hacking on control system access, and my customers say, oh, you can extract my data, I don't understand. And you can put something inside. It's like me, I can read because you can write, of course. And it's amazing, I don't understand. It's like that. You put some wire like electronic engineer and you can do something without any electronic skill. Okay, a very common sentence, industry need to take care about device security, of course, and Hardsploit shop is available, but sorry, but we are sold out due to Black Hat and other conference. We don't have any more Hardsploit. In fact, it's not true because the batch is finished, but we need to test before sale. So we have a lot of Hardsploit available, in fact, but not for the moment. It's only available at the end of August. If you have any question, don't hesitate. We are for that. Thank you very much, and have a nice meal.
Just one question. What is the maximum sampling frequency of your device?
For SPI to see or the FPGA frequency? All?
All.
So the FPGA works at 150. So in fact, it's not a real frequency. The information is a latency. And the latency for your information is 6.6 nanoseconds. I can do something each 6.6 nanoseconds. But after that, it depends on the length of your wire and the quality of the connector, etc., etc. So you can use SPI at 25 megahertz. In fact, it works until 75 megahertz, but it depends on your length of your file. Wire, and the speed is not very interesting things because it depends. If you are in standalone and you need to just to extract the data, you can obtain a gain of 2. It's very interesting, but it depends on the overload of your protocol. For example, for USB, it's not possible for 12 megabytes per second to have more than, in fact, 100 kilobytes per second. It depends on your system, if it's a virtual machine, etc., etc. So you can go up to 75, but you can't read more data because, in this case, USB is too low. But I agree with you in case of sniffing, but not for interact, because you have the time for interact.
Yeah. Okay, but
and for I2C, it's all the.
If you are limited to 75 megahertz, what is the point of using an FPGA? You can do everything in a microcontroller.
Yeah, but in microcontroller, in fact, when you put SPI memories, you put a very close SPI memory with very short wire. I'm not sure, you need to demonstrate me, it's possible to use a wire with 20 centimeters and to obtain a very big square form at 75 megahertz. It's not possible, but it's not a problem in case because you have some threshold at the clock of your memory, and the clock can be interpreted very well. It depends on the hardware. It's true, you can, but if I put the SPI very close. In case of FPGA, SPI memory is the case. My memory is very fast to do that. But when you read some headers and wire, it's not possible to do that.
Yeah, but as you said, with the right tool, you can do everything with the microcontroller. So I'm trying to understand why you put an FPGA there, and why, where are the limitations?
Yeah. Why are the limitations of
where are the limitations?
Ah, okay. It's just if you need to do something more with less than 6.6 latency, it's not possible because it's the speed of my FPGA. And why FPGA is very interesting? Yes, in case of SPI, you have SPI. In case of I2C, you have I2C. But if I want 20 I2C, I can, you can't. Because it's hardware implementation of I2C. In case of FPGA, I need just to copy and paste. And I can do all the process. For example, if I want to do some I2C bridge, I can in I2C. I2C in microcontroller is possible because it's very low speed, but for example, SPI you can't. It depends. For the moment, I agree, SPI is not very interesting to have FPGA to do these things because you have a lot of things on microcontroller. Of course, because when you want to audit something, we have SPI. So you don't need, of course, an FPGA to do something with SPI. In case of a very fast speed, all people are limited by the hardware. And trust me, you can't have a very clean square waveform at 75 with a probe system. Yeah. But it's a very big issue if you want to sniff something, in fact. It's for that, sometimes it's more powerful to remove the memories and read, read on an offline board. And another issue with sniffing is you sniff only what the microcontroller wants to read. If you want to read all the content of the memory, you can't with sniffing most of the time. It depends. It's before booting, maybe you can extract all the content. But most of the time, external memory, you can just read something. Sometimes it's just few bytes, and you spend your time because you can't extract all the content. Yeah. Some questions, or you want to eat something? Have a nice meal.